Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to talk about secant. So let's start with what is secant? Well, secant is the reciprocal of cosine. If you don't know what that term means, I made a video on it. But reciprocal basically means 1 over something. So secant is 1 over cosine. Cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So if we go to our right triangle, which legs labeled AB and hypotenuse C with angle X we are looking for. Cosine of X is equal to B over C, but secant of X equals C over B. Now we have our 30, 60, 90 right triangle and our 45, 45, 90 special right triangle. Then we have our unit circle. So let's look at cosine for our table, and then we will translate that to secant by doing 1 over whatever the output was. So I'll just read off a couple values. 0, 1, pi over 6, root 3 over 2, pi over 4, root 2 over 2, pi over 3, 1/2, pi over 2, 0. And then we'll keep going to pi over 3, negative 1/2, 3 pi over 4, negative root 2 over 2. But we're really, when I'm graphing, I'm only going to be using pi over 4s. So pi, negative 1, 5 pi over 4, negative root 2 over 2, 3 pi over 2, 0, 7 pi over 4, root 2 over 2, and 2, pi is 1. So I just graph pi over 4s because I like the scale. So if we do 1 over those values, 0 gave us 1. So 1 over 1 is equal to 1. Then pi over 4 is root 2 over 2. If you wanted to do 2 over root 2, then you'll go 2 root 2 over 2. Cancel 2's, you'll have root 2. Or you go to pi over 4, and you say, okay, hypotenuse over adjacent. Root 2 over 1 is root 2. Then we'll go to pi over 2, which is 0. 1 over 0 is undefined. We have an asymptote at pi over 2. Then 3 pi over 4, we have the same as pi over 4, but negative because we are in the second quadrant. So it is negative root 2. At pi, we have negative 1. At 5 pi over 4, same as pi over 4, which is root 2, but negative because it is in the third quadrant. So we have negative root 2. At 3 pi over 2, we are undefined because it is 1 over 0. Then at 7 pi over 4, we have the same as pi over 4 in quadrant 4, so it's positive. So we have root 2. And at 2 pi, we have 1. So let's get started graphing. We will graph 0, 1, and then pi over 4, root 2. So we have an asymptote at pi over 2. So this end coming off 0, 1 is going straight up towards that asymptote. And on the other side, there will be another asymptote at whatever, negative pi over 2, and that'll just be going up, again, racing towards the asymptotes. But we got a full graph here in the middle. So at pi, we have pi comma negative 1. So we got a good point there. Then 3 pi over 4 is negative root 2, and 5 pi over 4 is negative root 2. So we're going down towards the asymptotes. Kind of looks like a parabola, but with asymptotes. Then at 2 pi, again, we'll have 1. 7 pi over 4, we'll have root 2. So what happens is it's an alternating pattern of first at 0, we're going up, like curved, cupped up. Then at pi, we'll be going cup down. Then at 2 pi, we'll restart the cycle and cup up again. So every pi over 2, well, at pi over 2, there's an asymptote. At 3 pi over 2, there's an asymptote. I'm going to guess at negative pi over 2, there's an asymptote. And at 5 pi over 2, there's also an asymptote. So at pi x, our domain x is not equal to pi over 2 plus pi n. So going pi in any direction will give you an asymptote. So we're not equal to that. And then our range, y is greater than or equal to 1. So we sit on 1 and we go up. Or, well, it's an and y is less than or equal to negative 1. So we sit on negative 1 and go down. So the space in between negative 1 and 1 is not occupied. That is not in our range. So thank you for watching, and I hope this video on secant was helpful.